The next question before us is question number 11. It is one of the simplest questions. If a plus ib whole to the power of 5 is equal to alpha plus I beta, then b plus ia whole to the power of 5 is equal to the first option beta minus I alpha, second option beta plus I alpha, third option alpha minus beta, fourth option minus alpha minus I beta. Let us see what is given actually. A plus ib whole to the power of 5 is equal to alpha plus I beta. Therefore, a plus ib whole to the power of 5 bar is equal to alpha plus I beta bar. That is, I could have taken the complex conjugates on both the sides. What happens? This is nothing but a minus ib whole to the power of 5 is equal to alpha minus I beta. Isn't it? Okay. Now, let me write this a as minus I square a minus ib. Let us recall I square is minus 1. Therefore, minus I square is 1. 1 into a is a. So, there is no harm here in writing like this. Well, from this we have minus I into ia plus b whole to the power of 5 is equal to alpha minus I beta. Is equal to alpha minus I beta. That is minus I whole to the power of 5 into b plus ia whole to the power of 5 is equal to alpha minus I beta. Yes, we are approaching the required. We are required to have b plus ia whole to the power of 5, isn't it? We have got it. It's nothing but b plus ia whole to the power of 5. Well, what is minus I whole to the power of 5? Minus I whole to the power of 5 can be minus I whole to the power of 4 into minus I, isn't it? What is minus I whole to the power of 4 is 1. I power 4 is 1. 1 into minus I is minus I. Therefore, minus I into b plus ia whole to the power of 5 is equal to alpha minus ib. Now, let me multiply with I on both the sides. What happens? I into minus I square. Minus I square is 1. Therefore, LHS becomes b plus ia whole to the power of 5 is equal to alpha I minus I square beta. What is minus I square? It is 1. Hence, it is beta plus I alpha. Beta plus I alpha. Hence, the required answer is available in option B. That is beta plus I alpha is the correct option for this question. So, it's a very, very simple question which has been answered by justly taking the complex conjugates on the both sides of the given item, that is data a plus I beta to the power of 5 is equal to alpha plus I beta. Enough, that is the answer. That is option B. The next question before us is question number 12. The complex numbers a plus I, a minus I, 1 plus ai, 1 minus ai, where a is a real number taken in that particular order only on the organ plane, represent the vertices of a parallelogram. If he is asking us the value of a, so that those 4 vertices, 4 points on the organ plane form a parallelogram. The first option is a is equal to 1, second option is a is equal to minus 1, third option is a is equal to 0, and the fourth option is none. That's it. In the question, the 4 vertices are the points which are represented corresponding to the complex numbers. What are the complex numbers? A plus I, a minus I, 1 plus ai, 1 minus ai. A plus I is the point a comma 1. This is a comma minus 1, this is 1 comma a, and this is 1 comma minus a. Let me name these vertices as some A, B, C, D. Suppose A, B, C, D. If at all they form a parallelogram, everybody knows that diagonals bisect each other. Diagonals bisect each other. That is, midpoint of AC and midpoint of BD should coincide. What is midpoint of AC? A plus 1 by 2, A plus 1 by 2. A plus 1 by 2, A plus 1 by 2 is equal to midpoint of BD. What is the midpoint of BD? BD. A plus 1 by 2 minus of A plus 1 by 2. A plus 1 by 2. That must happen. Midpoint of AC, A plus 1 by 2, 1 plus A by 2. Midpoint of BD, A plus 1 by 2, minus 1 minus A by 2. Okay. By equating these two, the first coordinates, of course they are coinciding. Equating the second coordinates in the y coordinates in these points, A plus 1 by 2 is equal to minus A minus 1 by 2. Minus A minus 1 by 2. Bring minus A here, send 1 there, so that you have 2A is equal to minus 2, hence A is minus 1. What is A? Minus 1. Is it available? Of course available in the option B. The second option is the correct option. The next question is question number 13. Another simple question has come to us. Let us receive it carefully. 1 plus I into 1 plus 2I into 1 plus 3I into 1 plus 4I into etc. 1 plus ni. If at all it is alpha plus I beta, then what is 2 into 5 into 10 etc. 1 plus n square. That is equal to. The first option is alpha minus I beta. Second option is alpha square minus beta square. Third option is alpha square plus beta square. Fourth option is none. Let us have a look over the required one. What is required actually? 2 into 5 into 10 etc. You observe carefully. 2 is 1 plus 1 square, 5 is 1 plus 2 square, 10 is 1 plus 3 square, and then 1 plus 4 square, 1 plus 5 square, and so on up to 1 plus n square. He is asking us. Oh, it's very simple. You see, in the data 1 plus I into 1 plus 2I into etc. are given. So we are supposed to have their moduli. How can they be had? Let us see. What is given actually? Alpha plus I beta is equal to, what is given? Alpha plus I beta is equal to 1 plus I one plus ni. Well, let me find alpha minus I beta. What is alpha minus I beta? The conjugate of alpha plus I beta. That is, I am going to consider the complex conjugates of each and every complex number which is present on either side of this equation, both left hand side and or right hand side. What is going to happen? Alpha minus I beta is equal to conjugate of 1 plus I, conjugate of 1 plus 2I, conjugate of 1 plus 3I, etc. Conjugate of 1 plus ni. Now, think of the required. We need to have 1 plus 1 square, 1 plus 2 square, 1 plus 3 square, and so on. How can it be had? 1 plus I into 1 minus I, 1 plus I square, 1 plus 1 square. This is 1 plus 2 square. This is 1 plus 3 square. We have got the idea which is required, of course. So, you get to multiply this. You get these two multiplied. This is equal to 1 plus I into 1 minus I, 1 plus 1 square, 1 plus 2I into 1 minus 2I, 1 plus 2 square, 1 plus 3I into 1 minus 3I, 1 plus 3 square, 1 plus n square. What is 1 plus 1 square? 1 square is 1, 1 plus 1 is 2 into 5 into 10 into etc. 1 plus n square, which is of course the required. Now let us look at the fate of LHS. What is 1 alpha plus I beta into alpha minus I beta? It is of course alpha square plus beta square. And what is the answer present? alpha square plus beta square. It is available in option C. Therefore, option C is the right option, and the right answer is alpha square plus beta square. That's all the question. One of the simplest questions. Let us look at the next question, that is question number 14. In this question, he has given that z is equal to 1 plus I root 3 whole to the power of 10 plus 1 minus I root 3 whole to the power of 10. Then, what is argument of z? What is the argument of z? How can you get that argument? Let us look here. What is the given complex number? Z is equal to 1 plus I root 3 whole to the power of 10 plus 1 minus I root 3 whole to the power of 10 whole to the power of 10. You see, you please consider z bar. What can it be? What is z bar? Conjugate of z. What is the conjugate of 1 plus I root 3 whole to the power of 10? 1 minus I root 3 whole to the power of 10. What is the conjugate of 1 minus I root 3 whole to the power of 10? Nothing but 1 plus I root 3 whole to the power of 10. 1 plus I root 3 whole to the power of 10. What could you observe here? Z bar is equal to Z. Z bar is equal to Z. So, its conjugate is coinciding with this. What happens when such things occur? It's very simple. You can imagine. Suppose A plus IB is a complex number, is coinciding with A minus IB. What is the consequence? You can cancel A. IB plus IB is 0. That is B is 0. As B is 0, it is purely real. It is purely real. Implies Z is purely real. Is purely real. That is, it can be expressed on the real axis only, that is on x-axis. So, what happens to the argument of Z? Either 0 or pi. Either 0 or pi. It is a simple thing. So, the main thing here is you may have to observe Z is equal to Z bar. Not only that, as Z is equal to Z bar, you must recognize that Z is purely real. As it is real, it can be expressed as on x-axis, that is real axis. So that its argument is either 0 or pi. Either 0 or pi. And among the options, pi is given. Pi is given. Therefore, what is the right option? Option B is the correct option among the given. The next question before us is question number 15. If the complex numbers Z1, Z2, Z3, three complex numbers Z1, Z2 and Z3 are satisfying, 3Z1 is equal to 5Z2 minus 2Z3, then Z1, Z2, Z3 lie on a circle, a parabola, a line or a hyperbola. What is given actually? 3Z1 is equal to 5Z2 minus 2Z3. It's a very simple idea. What is the coefficient of Z1 here? 3. What is the sum of the coefficients on the right hand side? 3. It does mean they are collinear. Yes, they are collinear. So they should lie on a line. And in order to understand it very clearly and in a straight way, you observe. It is 5Z2 is equal to 3Z1 plus 2Z3. Therefore, Z2 is equal to 3Z1 plus 2Z3 by 5. I do not write 5. I like to write 3 plus 2. What do you understand by looking at this? If you can represent these three complex numbers Z1, Z2 and Z3 on the orthographic plane, 3 points will definitely come. The point corresponding to the complex number Z2 divides the segment joining those of Z1 and Z3 in the ratio 2:3 internally. In the ratio 2:3 internally. Such type of division is possible when and only when those 3 points are collinear. That is, they should lie on a line. You can understand that. Without using this step, by looking at the first step itself, you can recognize that those 3 points are surely collinear. That is, they form a line. Hence, they should lie on a line. Option C, that is the third option, is the correct option. Let us turn our head towards the next question, that is question number 16. If Z1 and Z2 are two complex numbers satisfying the equation mod Z1 plus Z2 by Z1 minus Z2 is equal to 1, then Z1 by Z2 is a number which is first option positive real, second option negative real, third option either 0 or purely imaginary, none of them. These are the four options. In the present question, he has given us the information about two particular complex numbers Z1 and Z2. How are they behaving? What are they satisfying? Mod Z1 plus Z2 by mod Z1 minus Z2 is equal to 1. Then what is the character of Z1 by Z2? One thing you have to understand here, he has asked us about Z1 by Z2. There itself we may have to believe that Z2 is a non-zero complex number. Unless or otherwise he may not ask you about Z1 but Z2. Yes, of course, Z2 is a non-zero complex number. Well, let us think of what is that. What is the given condition that is going to be satisfied by those two complex numbers given, that is Z1 and Z2? Modulus of Z1 plus Z2 by Z1 minus Z2 is equal to 1. Isn't it? Yes. We are assured of the fact that mod Z2 is a non-zero complex number. Therefore, let me divide this internally with Z2 so that it becomes Z1 by Z2 plus 1 minus 1 is equal to 1. Z1 by Z2 plus 1, Z1 by Z2 by Z1 by Z2 minus 1 is equal to 1. That is mod Z1 by Z2 plus 1 by mod Z1 by Z2 minus 1 is equal to 1. Thereby we observe that modulus of Z1 by Z2 plus 1 is equal to modulus of Z1 by Z2 minus 1. At this moment, let us recall that if at all mod Z plus A is equal to mod Z minus A, then the locus of Z is the perpendicular bisector of the line segment joining the points A0 and minus A0. According to that, if you can consider Z1 by Z2 as some Z, then mod Z plus 1 is equal to mod Z minus 1. So Z lies on the perpendicular bisector of the segment joining 1, 0 and minus 1, 0. 1, 0 and minus 1, 0, they lie on x-axis. The perpendicular bisector is just nothing but y-axis. Therefore, Z lies on y-axis. So, Z is either 0 or purely imaginary. You can easily understand that. Therefore, Z is either 0 or purely imaginary. Why? Because it should lie on y-axis. That is, Z1 by Z2 is purely real or purely imaginary, or it may be 0 because it is supposed to lie on y-axis. Hence, what is the right option? Option C is of course the correct option here. Let us look at the next question. That is question number 17. He has given us the information about three complex numbers Z1 and Z1, Z2 and Z3. Mod Z1 is 2, mod Z2 is 3, mod Z3 is 4, mod of Z1 plus Z2 plus Z3 is 5, then 4 Z2 Z3 plus 9 Z3 Z1 plus 16 Z1 Z2 is its modulus is. Mod 4Z1 Z4 Z2 Z3 plus 9 Z3 Z1 plus 16 Z1 Z2 is how much? You observe the required very carefully. Some hint will be available in the question itself so that we can trace the answer very easily. Let us first of all grasp what are all the things given. First one given is mod Z1 is equal to 2. Next one, mod Z2 is equal to 3. The next one, mod Z3 is equal to 4. And the last one, mod Z1 plus Z2 plus Z3 is equal to 5. Those are given. Then what is asked? Modulus of 4 Z2 Z3 plus 9 Z3 Z1 plus 16 Z1 Z2. That has been asked. Well, inside the modulus of the required item, first coefficient is 4. I like to write 4 as 2 square. That is mod Z1 square I like to write. Come on, take it. Is equal to mod Z1 square Z2 Z3. Just like that, 9 can be taken as mod Z2 square. Mod Z2 square Z3 Z1. Likewise, 16 can be taken as mod Z3 square. Mod Z3 square Z1 Z2. That is the required. Now, what is mod Z1? It is just nothing but Z1 bar. This is equal to modulus of Z1 bar Z2 Z3. Again, what is mod Z2 square? Z2 bar. That is Z2 bar Z3 Z1 plus what is Z3 mod Z3 square? Z3 bar. Z3 bar. Now, from this lengthier expression, I like to get mod Z1, mod Z2, mod Z3 out. What happens? Mod Z1, mod Z2, mod Z3 out. So that it is modulus of Z1, Z2, Z3. Mod Z1 plus Z2 plus Z3. You can easily observe. So that we know the value of every piece here present on the right hand side. What is mod Z1? It is 2. What is mod Z2? It is 3. What is mod Z3? It is 4. What is mod Z1 plus Z2 plus Z3? It is 5. So the total answer becomes 120. Is it available? Yes, of course. It is available in the fourth option, that is option D. Option D is the right option and the right answer is of course 120. That is about the question. The crucial point in making an attack on the question is you are supposed to make use of 2, 3, 4, 4, 9, 16. You can see 4 as 2 square, that is mod Z square. 9 as 3 square, that is mod Z2 square. 16 as mod Z3 square. By getting the simplification as shown in the solution, we can have the answer as 120. We shall now see the next question, that is question number 18. Another beautiful question we're going to have. Let us receive it carefully. The value of sine of log of cos pi by 2 plus I sin pi by 2 whole power z to the base e is. So many functions are involved here. A sine function, logarithmic function and e power I theta function, like that. So we have to deal with it very carefully, where z satisfies the equation mod z minus 2i is equal to 1 and has the least modulus. Z is a peculiar complex number satisfying mod z minus 2i is equal to 1 and has the least modulus. Yes, you have to understand the locus mod z minus 2i is equal to 1. What is that actually? What is mod z minus 2i is equal to 1? It is just nothing but a circle. Just nothing but a circle with center as 0, 2 and the radius as 1 unit. Yes, you have to understand it. In the previous sections itself, in the earlier stages of synapses of complex numbers, we could have noted that mod z minus a is equal to k is a circle with the center as the complex number a and the radius as k. Yes, here the center is 2i. So mod z minus 2i is equal to 1 must be understood in the beginning. What do you mean by mod z minus 2i is equal to 1? Even if you forget that, you can trace it on this part. If you take z is equal to some x plus iy, it is x plus y minus 2 into I modulus of is equal to 1. Square it on both sides. What are you going to have? X square plus y minus 2 whole square is equal to 1. It is not just nothing but a circle with center 0, 2 and radius 1. Let us trace the circle. Observe the circle. Its center lies on y-axis because x coordinate is 0. 0, 2. Because the complex number 2i is nothing but 0, 2. It is the center and the radius is 1. How can we trace it? Is equal to 1 is present. Therefore, it is a circle with center 0, 2 and radius 1. Our z, that is the heroine of the problem, lies on the circle with center 0, 2 and radius 1. It can stay here, 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 here or anywhere on the circle. No doubt. Another information has also been given here. What is that? And having the least modulus. That is, it is having the shortest distance from the origin. What is that point? It is just nothing but this point. Just nothing but this point. What has he said about z? The first point is the z satisfies the equation mod z minus 2i is equal to 1. What does it mean? Of course, it lies on the circle with center 0, 2 and radius 1. Okay, you can understand that z is a point on the circumference of the circle. Besides that, he has given us another useful information about z. What is that? And has the least modulus. What do you mean by modulus? It is just nothing but the distance from origin, isn't it? So, what is that point on the circle which is the nearest from origin? Come on, it is just nothing but this. What is this point? It is origin, this is 2 units, therefore this is radius is 1 unit, hence this is 1 unit, hence this point is 0, 1, implies z is equal to I, isn't it? Z is equal to I. The point 0, 1 on the orgone plane is just nothing but the complex, it is nothing but the point corresponding to the complex number I. Yes, therefore z is I. Okay. We have known about z. Now, what is required? What is required? A combination of 2 to 3 functions have been given in that lengthy expression. What is that expression? Come on. Sine of log to the base e of cos pi by 2 plus I sin pi by 2 whole power z. Whole power z. That is the expression given. Let us start simplifying it. It looks so bulky here. Is equal to sine of log to the base e of what is cos pi by 2 plus I sin pi by 2. It is just nothing but e power I pi by 2 whole to the power of z. That has been given. Now e power I pi by 2 whole to the power of z. You see, you could have believed, I mean, cos theta plus I sin theta is nothing but e power I theta by, of course, Euler's definition. Yes, of course. Well, this is nothing but sine of log to the base e of e power theta whole power z, that is e power I pi by 2 z. I pi by 2 z. Now, let us make use of the properties of logarithms. This is base e, this is the e, here also the base e. Therefore, the entire expression inside the brackets is nothing but sine of I pi by 2 z. Sine of I pi by 2 z, because let us recall the formula of logarithms. Log of a power x to the base a is nothing but x. Log of a power x to the base a is nothing but x. Base and this number both the same. Well, this is sine of I pi by 2 z. Now we enjoy the fruit of estimating z in the beginning itself. We could have understood the nature of z. It is exhibiting two types of character. Number one, the first type of character is it lies on the circle, and the second one is it is having the least modulus, that is nearest from origin. What is such z? Z is I. We must feel happy now because we could have estimated z in the beginning itself. What is z? I. You just substitute I in the place of z. What happens? I into I? I square. What is I square? Minus 1. So it is sine of minus pi by 2. Is equal to, what is that? I into I square. I square pi by 2. What is I square? Minus 1. So it is sine of minus 1 into pi by 2 minus pi by 2. What is sine of minus pi by 2? Minus 1. Is it available among the options? Surely it is available in the option C. Therefore, the right answer is minus 1 and the right option is C. A beautiful question, really a beautiful question. To answer this question, you must be able to understand the nature of z. What type of z has been given in the problem. Therefore, the main item, that is z, that is the heroine of the problem, yes, of course, is z is equal to I. You have to trace that idea. Unless or otherwise, it is not possible to estimate it quickly. Yes, there might be so many other ways, so many other methods to have it, but it is one of the simplest ways. Hence, the answer is minus 1 for this question. That is option C. The next question is question number 19. If c square plus s square is equal to 1, then 1 plus c plus is by 1 plus c minus is is equal to. First option, c minus is. Second option, c plus is. Third option, c plus ic. And the fourth option is s minus ic. Let us see. What is given? C square plus s square is 1. We are supposed to make use of that in due course of simplification. And then what is the actual complex number whose value is to be found? 1 plus c plus is by 1 plus c minus is. Let us now multiply both numerator and denominator with the conjugate of the denominator, that is 1 plus c plus is into 1 plus c plus is by 1 plus c minus is into 1 plus c plus is. Now, let us expand the numerator. 1 plus is into 1 plus is, 1 plus c whole square, is into is, I square s square, that is minus s square. This is the real part. Now the imaginary part, I into, come on, I into s into 1 plus c, I into s into 1 plus c. That is about numerator. Come to deal with the denominator. What has been there present in the denominator? a minus ib into a plus ib. What is that? A square plus b square. According to that, it is 1 plus c whole square plus s square. Plus s square. Let us expand this. 1 plus c whole square. 1 plus c square plus 2s minus s square plus 2i into s into 1 plus c by, this is 2s into 1 plus c, isn't it? I have written 2 here, 2i into s into 1 plus c by 1 plus c square plus 2c plus s square. Now this is the right time for us to make use of the inequality c square plus s square is equal to 1. Now c square plus s square is equal to 1. Then what is c square? 1 minus s square. Therefore, in the place of 1 minus s square, what can you have? C square. Therefore, the numerator becomes c square plus 2s plus, while expanding 1 plus c whole square, 1 plus c square plus 2c you must have, not 2s. Well, 1 minus s square is c square plus c square plus 2c, not 2s, 2c. Here 2is into 1 plus c denominator by, what is c square plus s square? C square plus s square is 1. This is 1, this is 1. Total 2. 2 plus 2c. Again, let us simplify the numerator still. What is c square plus c square? 2c square. 2c square plus 2c. 2c square plus 2c plus 2is into 1 plus c by 2 into 1 plus c. Again, this is 2c into 1 plus c plus 2is into 1 plus c by 2 into 1 plus c. You can cancel 2 into 1 plus c in both numerator and denominator. What are you having? C plus is remained there. Therefore, what is the answer? C plus is, that is option B. Hence, it is just nothing but a matter of simple calculation. You must be able to get this idea, and it's not impossible. Any person get this because it is a matter of multiplying with the conjugate. Yes. So, what is the right option? C plus is the right answer, and the right option is option B. We now see the next question before us, that is question number 20. If omega different from 1 be a complex cube root of unity and 1 plus omega whole power 7 is equal to L plus m omega, then the value of L plus m is, that is the question. What is asked? L plus m. From where are you getting L and m? 1 plus omega whole power 7 has been expressed in terms of omega as L plus m omega. So it is no doubt essential to have the value of L and value of m also. First of all, what is the given equation? 1 plus omega whole power 7 is equal to L plus omega. That is, what is the given equation? 1 plus omega whole power 7 is equal to L plus m omega. Let us now recall the properties of omega, the complex cube root of unity. What are the properties? Number 1, 1 plus omega square is equal to 0 and omega cube is equal to 1, and any number occurs as the exponent of omega. If it is in the form 3n, then also it is 1. Okay, let us make use of that. Look here. In the place of LHS is equal to, in the place of 1 plus omega, can I write minus omega square or not? Of course, minus omega square. Because 1 plus omega square is 0, we will be able to have 1 plus omega is no doubt minus omega square. Minus omega square whole to the power of 7. What is that? Minus omega square whole to the power of 7 is minus omega power 4t, right? Correct. As this is an odd number, this is a minus omega square. This is minus 1 into omega square whole power 7 minus 1 whole power 7 into omega power 4. That is minus omega power 14. Now this can again be written as minus omega power 12 into omega square, right? Why do you prefer to like this, to write like this? Omega power 12 is 1. Why is it 1? You can imagine omega power 12 as omega cube whole to the power of 4, isn't it? But we know omega cube is 1. 1 power 4 is 1. Ultimately, you will be getting it to be some minus omega square. But of course, in the place of minus omega square, we can again replace 1 plus omega. Well, LHS is 1 plus omega, RHS is L plus M omega. What can you have? What can you have? Therefore, 1 plus omega is equal to L plus M omega. Hence, by comparing L is equal to 1 and M is equal to 1, we do not want to have the values of L and M actually. We want to have the value of L plus M. You just add them. What do you want to have? L plus M is equal to 2. Therefore, option C is the right option. Value of L plus M is 2. Hence, option C is of course the right option as it is available in option C. Right answer is 2. Right option is C.